Welcome to this Space Oddities snippet, created in association with our sponsors, Rover Valley Optics. The question being asked today is, do the phases of the Sun's 11-year sunspot cycle increase volcanic eruptions here on Earth as it reaches its maximum activity? I think the best way to tackle this question is to break it up into different topics, like what inspired the question, historical evidence of a link, research papers, sunspot cycles, heliosphere, how do the sunspot phases affect the Earth, and possible explanations. We will cover these topics, but most likely not in this order. So, what inspired the question? Does an active sun like this on the left create increased volcano eruptions like this on the right? I personally have noticed an increase of volcanic eruptions all over the world over the last couple of years. Iceland, Italy, Indonesia, Russia, Japan, the Indian Ocean, Hawaii, even the Canary Islands. Famous names like Vesuvius, Etna, Stromboli, Krakatoa, etc. are all showing signs of increased activity. Maybe this perceived increase is due to increased exposure on social media like YouTube and dedicated volcano or crater cameras. You can watch a volcano erupting in real time at any time. At the same time, we also happen to be in the ramping up stage of sunspot activity of the Sun's 11-year cycle 25, which started in December 2020. This selection of images you are seeing now were of eruptions over the last 2 years, but there have been many, many more. As you are probably aware, the majority of Earth's volcanoes lay on the boundaries of the Earth's tectonic plates and fault lines, with others sitting on thin parts of the crust or where the makeup of the crust allows magma to rise up through fissures in the mantle. Types of volcano eruptions vary from being large flows of lava to huge explosive eruptions, throwing large volumes of volcanic gas and dust high into the atmosphere. These types of eruptions are categorized using the Volcanic Explosivity Index, or the VEI. This index rates volcanoes from 1 to 8 and measures the amount of volcanic pollution each volcano produces during an eruption and how high into the atmosphere the pollutants get. A VEI equaling 6 or 7 are the highly explosive volcanoes, like the phreatomagnetic eruptions, which is when the magma passes through water or ice, creating a very violent eruption, hurling tons of gas and ash miles up into the upper atmosphere. This ash plume then spreads out around the Earth, blocking the sun's radiation, and so reduces the temperature of the atmosphere and can cause a volcanic winter. Please remember that for later. Also, there have been historical links of possible volcanic eruptions and sunspot cycles made in the past. Next, I think a look at what a sunspot cycle is. And here I must issue a grave warning. Never observe the sun through a telescope, binoculars, or even with the naked eye. You will seriously damage your eyesight, so please be warned. When we look at the surface of the sun using the correct protective equipment, we can sometimes observe dark spots, and these are the sunspots. The sunspots appear in cycles going from lots of spots at maximum activity to few or zero spots at minimum activity. The Sun, like Earth, has a north and south poles. These will swap by the end of the 11-year cycle. When this happens, a new 11-year cycle will begin. The cycle has 4 phases: growth, maxima, descent, and finally minima. Here is the Sun at its sunspot minimum, and if you look closely at the top you'll see a silhouette of the International Space Station. It's a 2-for-1 image, this. It is accepted that a whole cycle takes around 10.7 to 11 years, but they have been recorded as short as 8 years to as long as 14 years. You can't really set your watch by them, they're that unpredictable. This butterfly diagram shows cycles back to the late 1800s to the present day. Cycles are also declared as active cycles or minima cycles, but this can only be determined after the whole cycle is complete, the whole 11 years. If several minimum cycles follow each other over decades, we are said to be in a grand solar minima. These have been known to last almost 100 years. This also can reduce atmospheric temperature. For an answer to our question, we need to observe 2 cycles covering a lead north and a lead south over 22 years. I will tell you more about that later. The sunspots at maximum activity will appear in both the northern and southern hemispheres of the Sun between latitudes 30 degrees north and 30 degrees south of the equator. When the Sun is in decline phase, the sunspots will decrease in number and will move towards the equator. With this migration of sunspots towards the equator, magnetism at both the north and south poles weakens, and this eventually leads to the flip of the poles. What is a sunspot? Sunspots can be very large or small, either be solo or in a group. A sunspot is in fact 2 spots, one with a north polarity and the other with a south. A sunspot is created by the erratic magnetic activity on the Sun's surface. Magnetism breaks away from the surface and creates an arch of magnetic lines connecting the 2 holes, along which magnetism and surface material or plasma will also flow. This is what gives us prominence on the edge of the Sun. The tension in the magnetic flow in the arches becomes distorted and twisted until they snap, giving us solar flares or coronal mass ejections, CMEs, throwing out into space huge amounts of electronic particles, as seen in this image. The next important Sun fact is that it constantly emits highly energetic particles that flow out into the solar system and bathe the Earth with light and warmth. This is called the solar wind or space weather. But to ensure we don't get too much radiation reaching the surface, which would be bad for life on Earth, we have our own magnetic field deflecting it away. This image shows the Earth's magnetic field deflecting the solar radiation around us so as protecting the Earth's surface. But you can also see that the solar wind pressure is actually squeezing the magnetic field and our atmosphere. The solar winds push out beyond the orbit of Pluto and has embedded in it its own magnetic field. This magnetic field prevents cosmic rays from penetrating all the way to Earth. Cosmic rays are very high energy particles that travel nearly at the speed of light from outside the solar system. So the solar winds also act as a shield, protecting us from radiation from outside the solar system. So that's all I want to say about volcanoes and the sun at this point. I hope you're still awake. So back to our question. And what are these historical links that I mentioned earlier in the topics? You may have heard of the Maunder minimum, which lasted between 1645 and 1715, where very little sunspot activity was observed, i.e. between 1672 and 1699, only 50 sunspots were recorded as compared to 40,000 to 60,000 that should have been seen over that period of time today. The atmosphere temperature at this point dropped by 1 to 2 degrees, causing great hardship. It was dubbed the Little Ice Age. But add to that, the minimum coincided with increased volcanic eruptions that happened before, during and after the Maunder minimum, that created a volcanic winter that lasted for years. Other minimums also seem to coincide with volcanic eruptions. The Dalton minimum, corresponding to sunspot cycles 4 to 7 from 1795 to the mid-1820s, again produced a temperature drop of over 1 degree, causing the rivers to freeze in Europe during winter. Extreme weather patterns were recorded all around the world and inspired George W. Galt to write The Year with No Summer in 1816, which again was attributed to a highly explosive eruption of Mount Tambora in Indonesia the year before, which was one of the 2 largest explosions in the past 200 years. Sorry, that was meant to be 2,000 years. Both these events occurred during periods of grand solar minima, GSM. This is the first curveball pitched to us regards our question. We asked about the sunspot activity at the maximum phase of the cycle. Now, let's just take a quick look at the research articles covering this question, and there was lots of it. This is just a small fraction of what I printed off and downloaded. It was all very interesting stuff. Of course, many of the research papers were concerned more as the effects of the sun activity has on the Earth's weather. Over the long term, the sun's cycles is the main driver of the weather and climate on Earth, and this has been known for a long time. During periods of high activity, lots of sunspots, we are treated to lovely auroras. But on the other hand, at low activity, few sunspots or none, we get a phenomenon known as high altitude blocking events. A high pressure sits over Greenland, Iceland and northern Canada during winter. An active sun means Earth experiences more space weather in the form of increased solar winds, more radiation from higher energy particles from the sun, and distortion of our magnetosphere, which protects us from the aforementioned radiation. The surveys were done using historical data and records of sunspot counts made over hundreds of years, but these are only good to when proper sunspot counting occurred. The same with witness records of volcanic eruptions all around the world. How many eruptions were not reported? Humans were not everywhere. Also used was the Volcanic Explosivity Index, VEI, to assess the amount of high-level ejecta that could have occurred. Older eruptions can be discovered analyzing ice cores, tree rings, stratification in soil or rock samples. The records are incomplete the further we go back. All this messing with the atmosphere is going to have consequences. As I said earlier, we have no positive theories of how this is all happening. We can see and measure the effects of the sunspot's activities on our atmosphere, magnetic field, and weather over time. We have records of volcanic eruptions and their VEI from around the world over hundreds of years. By comparing the two, we see that the link between the sun's 11-year sunspot cycles and the increase in volcanic eruptions is there at the maxima phase, but even greater at the minima phase. But to add to that, to muddy the waters even more, volcanic eruptions, there are more of them or greater amount when the cycle has a lead south component. And again, this goes back to the 22-year cycle. So, how does all this affect Earth? Before I can talk about this, I must first answer the original question. Do the phases of the sun's 11-year sunspot cycles increase volcanic eruptions here on Earth as it reaches its maximum activity? And the answer to our original question is yes. At the sun's sunspot maximum, its highest activity, volcano eruptions do increase. But more surprising, it appears that even greater number of eruptions occur at the solar minimum of the cycles. But it doesn't end there. To make it even more confusing, the biggest increase of volcanic eruptions is when the sun has a leading south polarity cycle and the sun is at its minima least active. So a less active cycle, which of course leads to a prolonged minima and has a lead south polarity, is more influential on Earth's volcanoes. That's a second curveball. This is why I said we need to observe two 11-year cycles covering both a lead north and a lead south cycle, 22 years in total. So why is this so? We're just not sure. Many theories have been proposed as to why this influence appears to happen, but none can be cited as proof. Three theories are worth repeating. Remember, most volcanoes sit on a fault line and where the Earth's tectonic plates meet, and it is also along these lines that most earthquakes and volcanic actions occur. Theory number 1. During the period of high sunspot activity, the increased solar wind compresses our atmosphere and so reduces our protection from the sun's solar radiation. At the same time, our magnetic field is also stretched and so weakening its shielding effects, as can be seen in this image. The increased radiation warms the atmosphere, altering the Earth's weather patterns. It also warms the Earth's crust, which as we know is a patchwork of different rocks with different properties. The different expansion rates of these rocks, plus the increased electrical flux in the magnetic fields of the fault lines warming the boundaries surfaces, cause slippage of the plates, hence more earthquakes and volcanic eruptions. Theory number 2 is that when increased or decreased sun activity interferes with the circulation of the weather patterns, it can abruptly alter the speed of the Earth's rotation. The resulting jolt may trigger the fault lines to slip, creating earthquakes and kicking off volcanic eruptions. Third and last theory. Low levels of activity expose the Earth to higher levels of cosmic rays from outside our solar system. During a period of solar minima, the solar wind weakens along with its magnetic field. That pushes out beyond the orbit of Pluto and stops most cosmic rays from penetrating into the solar system, which in turn results in protecting us from these high-energy particles. So, a weak solar wind means reduced solar wind magnetic field and so exposes Earth to a cosmic ray bombardment. The variation in intensity of cosmic rays varies globally by about 15% over an 11-year sunspot cycle. This image you're seeing now is cosmic rays hitting the Earth at different wavelengths. And the image on the bottom right is a composite of all the images put together, and you can see the increased bombardment of cosmic rays. As well as affecting weather, the increased radiation creates fluctuating electrical currents in the magnetic fields in the Earth's fault lines and tectonic boundaries, where the magnetism is already increased. This heats the surfaces between the boundaries, and the variations in the expansion due to differing rock makeup makes the two sides of the boundary more inclined to slip, again creating earthquakes and volcanic eruptions. As I said earlier, we have no positive theories of how this is all happening. So, has the link been made between the Sun's 11-year sunspot cycle, 22-year solar cycle, and the increased earthquakes and volcanic eruptions? Yes, it has. Do we know how this is all working? The jury's still out on that. A possible link is compelling, but it needs much more research to solve why and how this link is created. There is, of course, a lot more science in these papers that I could discuss, but I am not a scientist and it's probably best saved for another day. So why does this all matter? Well, as we have seen earlier, an enhanced number of volcanic eruptions can and has had a great effect on Earth's climate, cooling our atmosphere. If sunspots create more eruptions during the 11-year cycle, and that is increased by different factors during the solar cycle of 22 years, we would like to be able to predict what each cycle is going to do with regards to sunspot numbers produced. In other words, is the next cycle going to be an active cycle or a minima cycle? Also, if it is a minima cycle, will it carry on that trend for several years, like the Maunder minimum or the Dalton minimum? We know what happened then. We can see and measure the mechanics going on. We can see and measure the effects on the Earth. But with all this data, we are really no closer at predicting how each cycle is going to go. For example, Sunspot cycle 24 was considered a minima cycle, and it was predicted that our present cycle 25 would be a deeper minima. Some even went as far as to predict that we were entering into a greater solar minimum phase, and hence a possible ice age. Also, it was mooted that the maxima for cycle 25 would be in the year 2025. But that has now changed to 2024, possibly having a prolonged minima stage. We are hedging our bets. As I mentioned before, we will not know what cycle 25 will be rated at, active or minima, until it has completed its cycle, whenever that will be. And another interesting point to add to that last statement, cycle 24 is the only cycle to have actually lasted 11 years in length since records began. Until we really get to grips and understand the sun's crazy magnetic fields, I believe we have no way of confidently understanding sunspot cycles. Well, I hope you enjoyed that. If you did, don't forget to give us a like and give us a thumbs up. And don't forget to join us on Mondays at 8 p.m. UK time for the live show where you'll meet the panel and we discuss everything astronomical. Our motto is, if it's happening in space, it's happening on Space Oddities. So, bye for now.